Hello everyone, my name is Fuad Alqrinawi. I'm a PhD student at the University of Birmingham as part of the Plastic Underground Doctoral Network, and today I'm going to talk a little bit about my research topic, which is the fate and transport of microplastics in groundwater, at which I will be using some numerical modeling techniques. So let's go. Alright everyone, so in the coming few slides I will be talking in more details about my research topic, including my objectives, my methodology, and what kind of simulation you would expect to see. All right. So starting with the objectives, we're trying to develop and validate a predictive model that can accurately estimate the transport of microplastics in porous media. Also, we want to examine the impact of various environmental variables, including water flow and the porous media packing on the transport of these microplastics. And we need to understand how the number of microplastic or the concentration alongside with their density, sizes and shapes influence their breakthrough behavior, because we know there is a lot of types of polymer that will end up with the microplastics with different densities, with different properties, and also the size range of microplastics is very huge and we can't really treat all of them as one. In order to do that, we will be using an in-house finite difference multi-phase Euler and Lagrangian code, what we call multi-flow 3D. This will be our CFD tools, computation fluid dynamic, to model the microplastic transport in porous media. So this simulation will consist of three different phases. Starting with the continuous phase, which is the water here. This will be modeled by solving the Navier-Stokes equation, so continuity equation and conservation of momentum. And for the dispersed phase, which is the second phase here, it's basically will represent microplastics. So here we are solving it using a Newton's second law. So summation of forces equal mass by acceleration, and here you can see all the forces that acts on the particles. There's some obvious forces like the buoyant force and the drag forces, but also we include the fluid stress force, the added mass force, and the lift force. And probably the most important phase here is the solid phase, which is how we are going to actually simulate our porous media. In order to do that, we need to impose a no-slip boundary around fluid-solid interface. So we will need to create a solid boundary that represents our grains, and finally will represent our porous media, and then we will impose a no-slip boundary around them. So this means that no water or particle will be able to flow through these solid boundary, but rather they need to go around them following the pore space that will be created by the different packing of these porous media. Here you can see some of these simulations that will come out after using this multi-phase modeling approach. And here you can see some particles will just start moving with the flow, some particles that don't have any obstacle in their way, they will just move normally with the flow without any interaction. However, you can already see some particles being attached to the porous media, and once the concentration started to increase, more particles will start to attach, while some particles will just be able to go around these porous media spheres, and with the increasing concentration, you can see that this will promote more clogging, as the particle will be won't be able to move easily in these small pore spaces that's being created by these solid boundaries. So here you can see we already have attachment, we have clogging and accumulation of the particles when the concentration is increased. So this approach is really promising to simulate the microplastic transport in porous media. However, modeling alone won't be enough. For that, we will be doing some experiment in the lab, and that will be the last part of this video. So stay tuned. Thank you. Everyone again, and welcome to the Molecular Science Lab at the University of Birmingham. And here I will be doing my experiment in order to validate my model. So as you can see here, we have a 36 centimeter long column with 6 centimeter diameter, and it's filled with glass bead. Why glass beads? Because it's the simplest way in order to present porous media, basically. To look at the setup, we have here a water source at which the water will be pumped to the top of the column, and then the microplastic will be injected at the first few centimeters, and then it will allow to move with the water through the porous media itself. So here, as you can see, we have the outlet at which the water will be collected at different time intervals, at 5 minutes, 10 minutes, 15 minutes, etc. And after we finish all of that, we will take all of these water samples, and it will be filtered using GFD or GFF filters. And then we will take a look at those filters under the microscope in order to count the microplastic at different time intervals and get our breakthrough curve. So in this way, we'll have an idea about the peak concentration, the time to peak, and also if there is any tailing that's happening. And this will be very helpful for me in order to validate my model fully. So thank you so much for listening, and looking forward for good results. Thank you so much.